Building codes typically prohibit running subfeeders through the ceiling of another unit in a condominium project. The primary reasons for this restriction revolve around safety, accessibility, compliance with regulations, and privacy. Considering safety firstly, running electrical subfeeders through another unit's ceiling introduces potential electrical hazards. If the wiring is damaged, improperly installed, or experiences insulation failure, it can create a risk of electrical shock or fire within that unit. Limiting subfeeder routes to common areas reduces the risk of electrical hazards affecting individual residential spaces. Secondly, accessibility is a crucial factor. Electrical systems require periodic maintenance, inspection, and repairs. Running subfeeders through common areas such as electrical closets or utility rooms ensures that electricians and technicians can easily access the wiring without needing to enter private residences. This accessibility is essential for timely maintenance and troubleshooting. Thirdly, compliance with building codes and electrical standards is paramount. Building codes are designed to ensure the safety and proper functioning of electrical systems. Routing subfeeders through approved common areas helps to comply with these regulations. The National Electrical Code, or NEC, specifically addresses the installation requirements for electrical feeders and subfeeders, and local building codes often adopt or adapt these standards. Fourthly, privacy considerations play a role. Running electrical lines through another unit's ceiling infringes upon the privacy of the residents. It is a fundamental expectation that the building's infrastructure should not intrude into the private living spaces of individual unit owners. Common areas designated for subfeeder routing typically include electrical closets, utility rooms, attached garages if accessible by all units, and crawl spaces or attics if shared by all units. Electrical closets are specifically designed to house electrical equipment and wiring, making them an ideal location for subfeeder runs. Utility rooms, often housing equipment such as water heaters or HVAC systems, can also accommodate subfeeders if sufficient space and proper clearances are available. If attached garages are accessible to all units, they may serve as a viable pathway for subfeeders, provided that the wiring is protected and installed in accordance with electrical codes. Crawl spaces or attics, if shared by all units, can also be used for subfeeder routing, but these spaces must meet specific requirements for accessibility, ventilation, and protection of the wiring. It is important to note that the specific requirements for subfeeder routing can vary depending on local building codes and the configuration of the condominium building. Consulting with a qualified electrician or building inspector is essential to ensure compliance with all applicable regulations. The NEC provides detailed guidelines for the installation of feeders and subfeeders, including requirements for conductor sizing, overcurrent protection, grounding, and wiring methods. For example, NEC Section 310.15 addresses conductor ampacity, which determines the allowable current carrying capacity of conductors based on factors such as insulation type, ambient temperature, and the number of conductors in a raceway or cable. NEC Section 240.4 covers overcurrent protection, specifying the requirements for fuses and circuit breakers to protect conductors against overloads and short circuits. NEC Section 250.24 outlines grounding requirements for separately derived systems, ensuring that the electrical system is properly grounded to minimize the risk of electrical shock. NEC Section 300.11 addresses securing and supporting wiring, requiring that cables and raceways be securely fastened to building structures to prevent strain and damage. The choice of wiring method, such as conduit, cable tray, or direct burial, depends on the specific application and environmental conditions. Conduit provides the highest level of protection for wiring, shielding it from physical damage and environmental factors. Cable tray systems are suitable for routing large numbers of cables in commercial and industrial settings. Direct burial is permitted for certain types of cables that are designed for underground installation. When running subfeeders, it is essential to maintain proper clearances from other utilities and building components. The electrical wiring should be kept away from water pipes, gas lines, and HVAC ducts to prevent potential hazards. The NEC specifies minimum clearance distances for electrical wiring from these types of systems. In addition to safety and accessibility, aesthetics can also be a consideration when routing subfeeders. Exposed wiring can be unsightly and detract from the appearance of the building. Concealing wiring within walls, ceilings, or conduit can improve the overall aesthetics of the installation. However, it is important to ensure that concealed wiring is still accessible for maintenance and repairs. The use of junction boxes and access panels can provide access to concealed wiring without requiring extensive demolition. Regular inspections of subfeeder wiring are essential to identify and address any potential problems before they escalate into serious hazards. Inspections should be conducted by qualified electricians who are familiar with electrical codes and standards. During an inspection, the electrician will check for signs of damage, such as cracked insulation, loose connections, and corrosion. They will also verify that the wiring is properly supported and protected. If any problems are identified, they should be promptly repaired or replaced. In summary, running subfeeders through the ceiling of another unit in a condominium project is generally prohibited due to safety, accessibility, compliance, and privacy concerns. Subfeeders should be routed through common areas such as electrical closets, utility rooms, or shared crawl spaces to ensure compliance with building codes and electrical standards. Consulting with a qualified electrician or building inspector is essential to ensure that the subfeeder installation meets all applicable requirements. By following these guidelines, you can help to ensure the safety and reliability of the electrical system in your condominium building. When designing and installing subfeeders, it's crucial to consider the load requirements of the unit being served. This involves calculating the total amperage needed for lighting, appliances, and other electrical devices. The subfeeder must be sized appropriately to handle this load without overloading. The NEC provides detailed guidelines for calculating electrical loads and determining the appropriate conductor size. Voltage drop is another important factor to consider. Voltage drop occurs when the voltage at the end of a long conductor run is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction and reduce the efficiency of the electrical system. The NEC specifies maximum allowable voltage drop for feeders and branch circuits. To minimize voltage drop, it's important to use appropriately sized conductors and keep conductor runs as short as possible. Grounding is a critical aspect of electrical safety. The grounding system provides a path for fault current to return to the source, allowing overcurrent devices to trip and to energize the circuit. The NEC specifies detailed requirements for grounding electrodes, grounding conductors, and bonding of metal enclosures. Proper grounding is essential to protect people from electrical shock and prevent damage to equipment. Surge protection is another important consideration, especially in areas prone to lightning strikes or power surges. Surge protective devices, or SPDs, can protect sensitive electronic equipment from damage caused by voltage spikes. SPD should be installed at the service entrance and at individual pieces of equipment. Regular maintenance of subfeeders is essential to ensure their continued safe and reliable operation. This includes inspecting conductors for damage, tightening connections, and testing overcurrent devices. A qualified electrician should perform these maintenance tasks on a regular basis. Documentation of subfeeder installations is also important. This includes keeping records of conductor sizes, overcurrent protection ratings, and grounding connections. This documentation can be helpful for troubleshooting and maintenance in the future. When making modifications to existing subfeeders, it's important to follow all applicable codes and standards. This includes obtaining necessary permits and inspections. Any modifications should be performed by a qualified electrician. In addition to the NEC, other standards may apply to subfeeder installations. These include standards from organizations such as UL, or Underwriters Laboratories, and ANSI, or American National Standards Institute. These standards provide requirements for the design, construction, and testing of electrical equipment. When selecting electrical equipment for subfeeder installations, it's important to choose products that are listed or certified by a recognized testing laboratory such as UL. This ensures that the equipment meets applicable safety standards. Proper labeling of subfeeders is also important. This includes labeling conductors, overcurrent devices, and junction boxes. The label should clearly identify the purpose of the wiring and the equipment it serves. Proper labeling can help prevent confusion and errors during maintenance and troubleshooting. The use of arc fault circuit interrupters, or FSIs, is becoming increasingly common in residential electrical systems. FSIs are designed to detect arc faults, which are a common cause of electrical fires. The NEC requires FSIs in many branch circuits that serve bedrooms and other living areas. While FSIs are not typically required for subfeeders, they can provide an additional level of safety. The use of ground fault circuit interrupters, or GFCIs, is also important in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to detect ground faults, which can occur when current leaks to ground. The NEC requires GFCIs in many branch circuits that serve these types of areas. When installing subfeeders in damp or wet locations, it's important to use wiring methods and equipment that are suitable for these environments. This includes using waterproof connectors and enclosures. The NEC provides detailed requirements for wiring in damp and wet locations. The selection of conductors for subfeeders should be based on several factors, including the ampacity of the circuit, the voltage drop requirements, and the environmental conditions. Copper conductors are generally preferred for their high conductivity and corrosion resistance. Aluminum conductors are also used, but they must be sized larger than copper conductors to achieve the same ampacity. The installation of subfeeders should be performed by qualified electricians who are familiar with electrical codes and standards. This ensures that the installation is done safely and correctly. The electrician should also be licensed and insured. Before starting any electrical work, it's important to disconnect the power supply to the circuit. This can be done by turning off the circuit breaker or removing the fuse that serves the circuit. It's also important to test the circuit to make sure that it is de-energized. The use of personal protective equipment, or PPE, is essential when working with electricity. This includes wearing safety glasses, gloves, and insulated tools. PPE can help protect you from electrical shock and other hazards. When working in confined spaces, such as crawl spaces or attics, it's important to take precautions to protect yourself from hazards such as falling debris, insects, and rodents. This includes wearing a hard hat, gloves, and a respirator. It's also important to have adequate lighting and ventilation. After completing the subfeeder installation, it's important to test the circuit to make sure that it is working properly. This includes checking the voltage, current, and grounding connections. It's also important to test the overcurrent devices to make sure that they are tripping at the correct current level. The final step in the subfeeder installation is to document the work. This includes creating a wiring diagram and labeling all of the components. This documentation will be helpful for future maintenance and troubleshooting.